this function x squared minus 4x minus 3, okay? X squared minus 4x minus 3. Very, very carefully over here. This thing over here tells you that your factors, if it's minus, the factors will have different signs, And if you notice that the factors over here will have different signs, that means that the factors have different signs, therefore the roots will also have different signs. In other words, one root or one x-intercept will be positive and the other one will be negative. That's of course if the thing has real roots. So let's solve this. X squared minus 4x minus 3, x squared minus 4x minus 3. Let's just get a new page going. X squared minus 4x minus 3. Now, here we need to look for factors of 3, that if I subtract those factors of 3, that if I subtract those factors, I must get an answer of 4. Now, the only factors of 3 are 1 and 3 because 3 is a prime number. And if you subtract 1 from 3, you're going to get 2. So this here, we say that these factors are not valid. And when you get a case like this, what you need to do is you need to start using the quadratic formula. And the formula, therefore, we must use the quadratic formula. At this point in time, guys, I really want to urge you, if you're watching this video as a spectator, just watching me do the mathematics, remember, that's not you. That is me. Okay? That's me understanding the work, me getting the work. And if you just copy it down, that's also not good enough. You need to work through it strategically, make sure you understand every part of it, learn actively, and make notes as I go along. And better yet, if you use a model which you try and teach us to a friend, that will be even better for you. Okay, so we cannot factorize, so we can't open up brackets here, so we need to use something called the quadratic formula. The quadratic formula says x equals minus b plus or minus the square root of b squared minus 4 times a times c, okay, all over 2a. Now the question is, what are the values of a, b, and c? Well, a's value is just this invisible one that you see over there, b's value is equal to negative 4, and c's value is equal to negative 3. That's my a, that's my b value, and that's my c value. These represent the coefficients of the variables. Okay, so now I substitute it in, and I know that this may be boring because it's easy work for you that you already know. This is x equals minus 4 plus or minus, this means that I have to do 2 calculations on the calculator, of b squared, which is minus 4 squared, right, minus 4 times the value of a, which is 1, times the value of c, which is negative 3. And let me just extend that line over there. And that's all divided by 2 multiplied by the value of a, which is 1. And this is going to give me x equals something and x equals something else, depending on whether this value is positive or negative. So let's put that in a calculator and see what we get. Okay, so if I round this off, my first value on the calculator is that x equals 4,65. That's when I use plus the square root. And when I use minus the square root, I get 0,65. Negative 0,65. And remember, I already told you at the beginning that if this last figure is negative, one of my roots is going to be positive and one of my roots is going to be negative. So there already we can start seeing some patterns. Okay, so at this point in time, we can clearly see that that is one value, which I'm going to call R1, which is root 1. And this over here is intercept number 2, so I'm going to call it R2. Now, very importantly over here, people, as you can see, there are 2 roots, right? That means that there are 2 x-intercepts. And when you get actual values, it means that this graph will touch the x-axis. It will touch the x-axis, right? That's the horizontal axis. So let's see what that actually looked like. So which curve is this? This is the curve of x squared minus 4x minus 3. And if you look at that, just look at that. Do you see there? That's our value, negative 0,65. And this is our value here, positive 4,65 that we calculated. And so that curve has one positive root, one negative root. The 2 roots are unequal. They are what we call distinct. They are not equivalent. They are different. And they are real because they actually touch the x-axis. Okay, and let's just see if that agrees with this over here. Does it agree? It agrees. Right, so we did it graphically and we did it by solving.